however you want to do it.
Oh, that's an angle, right? Not a L.
Where this,
At
that,
the very, right there, yeah,
that's an angle symbol.
okay.
Yeah, it looks a lot like my L, doesn't it?
The one on the bottom is an L, not an angle.
I'll do my angle symbol in here, or whatever.
Mark that.
Wait, okay, so it's 5 minus,
That's an L.
yeah, is that it? It's LW and then equal 5 minus.
There?
No. Yes.
5 minus 5.
Okay,
Basically, subtracting the angles there. Because this is e to the I5, this is e to the I5 minus pi over 2. When you divide, you subtract the exponents.
I'm sorry.
Doing something similar, I'm going to cut out some steps, but doing something similar with capacitance. I know the capacitive reactance is going to be the voltage over the current. This is going to be some amplitude with a phase shift of phi. This is going to be epsilon omega c. And I know that for a capacitor, the current leads by 90 degrees, so this would be phi plus pi over 2. So I end up with 1 over omega c, just doing the amplitude piece, and then my angles, it's going to be phi minus phi plus pi over 2, which gives us negative pi over 2. So I can express this, my inductive reactance becomes 16.9646J. And my capacitive reactance becomes 13.2629 negative J. That's negative pi over 2 puts us down. That's 1 over omega c negative J. What does this get us?
I don't know.
Once you recognize the inductor is just going to be the inductive reactance J, and the capacitance is the capacitive reactance negative J. I can now add these like resistors in series or resistors in parallel if I were given that. My impedance is my total resistance here, or resistance equivalent. It's going to be 15 plus 16.9646J plus negative 13.2629J. So that's 15 plus, that's 3 point something. Or 7. We'll just stop at 3.7J. Which means that my impedance has a magnitude of, well, 15 squared plus 3.7 squared. And an angle of the arctan of 3.7 over 15. And this is going to be 15.4464 or somewhere around there. And the angle should be 0.24.
.2418.
So my current is the voltage from the power supply divided by my impedance. So that's 169.7 at an angle of 0.523599 over 15.4464 at an angle of 0.2418. That will get me the magnitude of my current, and then this minus that gets me my phase shift, which would be somewhere around 0.2826. It gets us this. So we're getting the same information, just in a slightly different order.
Okay.
Yeah, for the first one. I think I would for the first one.
Personally, I feel like if it's a simple circuit, like it's a series or parallel, the first way is the simplest. If you end up with something more like the following, I think the second way is actually simpler.
I still don't understand the angle thing, the angle symbol notation, what are you doing there?
I'm just not bothered writing the repetitive part of all of it. That's all.
What?
It's just the angle simplifies cosine 376.99 radians per second t plus angle, or plus phase shift.
Plus what is, so the 0.52355, whatever on the top there next to the angle symbol is the phase shift?
Yeah.
I'm writing, the unique parts are the number up front and the phase shift.
Okay.
Those are the unique parts. That's all I'm representing here.
Okay.
In terms of what I had written down there, because remember that the phasor is A e to the j omega t e to the I 5. I'm writing just the phi part.
I mean, are you doing that just now, or is this like an official way to write it, like that we'll see?
I have seen this in enough places that I would call it official.
Okay.
I don't think the textbook, I think the textbook's just sticks with phasors. I'd have to double check that.
Yeah, I was wondering if you were just doing it on the fly here to make it easier or not, or whether
No.
like it's actually a thing.
It is a thing. The electric pheromones, that's something I made up. But this notation, I've taken from someone else. Now, they might have made it up, but I feel like I've seen it in enough places.
But in general, it usually means like a leading coefficient, like sine or cosine, and then another number?
The phase shift, I mean, how far?
Oh, yeah, the phase shift, yeah. Okay. There's always gonna be amplitude in front of the angle symbol? Or-
I've always seen it that way.
Okay.
Now, I know it's gonna bring you sadness. The class is over. Tomorrow, there's gonna be,
A quiz
Lab
over
that-
everything we just did.
the lab we're doing tomorrow is just an RC circuit, RC series circuit. Actually, it'll start out with just resistor, then it'll change that out for a capacitor, then you'll have an RC circuit. So, sorry, no inductor.
We don't have the lab the week after that, right?
Oh, is that Good Friday?
Yeah.
Hey, don't forget, as a public institution, we cannot promote any religion, except apparently Easter.
Yeah.
It's Good Friday or Religious
I think it's Good Friday.
It's a Good Friday because we don't have a lab.
Which means the lab's not due until 2
Yeah,
weeks.
Nice. I'll have 2 weeks.
Oh,
Instead of
By
one.
the way, if you have an inductor in the circuit, I haven't quite justified this yet, but if you have an inductor in the circuit, and you're trying to, you really want to do it properly. So if you're doing a lab and numbers aren't quite in and up, the inductors have a resistance. They have an inductance, as you would expect, and they also have a little bit of capacitance, called self-capacitance. I've read on it, but I haven't quite figured out what exactly they mean by that. But if I actually gave you a solenoid and threw that into the circuit, that would be the equivalent of having a pure inductor, a resistor, and then a capacitor in parallel with that. And not you, but someday I hope to be able to bring an inductor into it and subject further groups, later groups on it. So you can look back, and if you come back and visit and you see them doing the RLC AC lab, you can laugh at them. Or take it, one or the other. Anyway.
Looks like I'm on